John here from bootcamp.com, and in this video we're going to be taking a look at the anterior lateral system, or the spinothalamic pathways. We're going to be taking a look at the neurons involved, as well as the somatotopic organization that we see in one of these tracts. So without further ado, let's just jump into it. So if you recall, we're going to have our spinothalamic pathways right here and right here. This one on the lateral aspect, this is going to be our lateral spinothalamic pathway. And this one on the anterior aspect, this will be the anterior spinothalamic pathway. Now, one thing which you may have not realized, these actually carry different types of information. So the anterior spinothalamic pathway found right here, this is going to carry crude touch or gross touch. And this is similar to the anterior and lateral corticospinal tracts. Remember, the lateral corticospinal tract carried motor information for fine motor movements, and the anterior corticospinal tract carried information for more gross movements of the trunk and upper limbs. Think of the anterior corticospinal and the anterior spinothalamic carrying similar types in the sense that they carry more gross general types of information. And in the case of the anterior spinothalamic tract, it's crude or gross touch. So it's general touch sensation that you would feel on your body. Now the lateral spinothalamic tract, this is going to carry the remainder of the information that is both pain and temperature. So now let's draw out the pathway for our spinothalamic tract. And it's going to be similar to the dorsal column medial lemniscal pathways in the sense that it has 3 neurons, except in this one, they're arranged just a little bit differently. The first order neuron is going to be somewhat similar in a sense that the cell body is going to be found in the dorsal root ganglion, and the dendrites are going to be actually interacting with the sensory receptor to carry that information down the dendrites, past the cell body, and into the spinal cord. From here, it's going to synapse on an interneuron, or the second order neuron, which is going to be found in the dorsal horn. So that cell body in the dorsal horn, that belongs to the second order neuron. This will then decussate, and if this information is regarding pain or temperature, it's going to travel up our lateral spinothalamic pathway. And if it's carrying information regarding crude touch, then it's going to travel up our anterior spinothalamic pathway. So in this case, let's just say it's carrying information about pain and temperature and traveling up that lateral spinothalamic pathway. So it's going to leave the dorsal horn. So that second order neuron then decussates across the spinal cord and enters into the lateral spinothalamic tract. So this is where the crossing over happens. So in the spinothalamic pathway, the decussation is at the level, the spinal level, from where that information is coming in. Whereas in the dorsal column medial lemniscal pathway, remember that decussation is all the way up the brainstem, where we have the nucleus gracilis or the nucleus cunatus. So the decussation in the spinothalamic is at the level of the spinal cord where that information is coming in. It crosses over, and then this axon from our second order neuron is going to ascend the spinal cord, where it's going to reach the thalamus. Here, it's going to synapse with the third order neuron in the ventral posterior lateral aspect of the thalamus, and this neuron will then send its axon to the primary somatosensory cortex for it to be perceived by the brain. So let's say we have a lesion up here, because if you remember, the right side of the brain is perceiving information coming from the left side of the body, we would have a contralateral sensory deficit that would be perceived. Because the decussation happens over here, it's already crossed over and ascended. So this information is being cut off here, so the information from the left side of the body is not being processed. If we had a lesion down here in the first order neuron, then we would have ipsilateral sensory deficits, because the lesion is now on the same side as where we would expect to see sensory deficits. Let's go through one more example, and let's include the dorsal column medial lemniscal pathway. Let's say we had damage to this entire side of the spinal cord. What sort of sensory deficits would we see? Would they be contralateral or ipsilateral? Well, we have our spinothalamic pathway drawn out here, so we know that we would have contralateral sensory deficits for crude touch, pain, and temperature, because the lesion is going to be on the opposite side for where the sensory information is going to be deficient. Now, what would we have, or what will we observe in the dorsal column medial lemniscal pathway? Let's just get rid of our lesion for a second. If you remember, the information is going to come in and then travel up our dorsal column. Once it reaches the brainstem, that's where it decussates over. So we're interfering with the pathway before the point of decussation. So what would we experience? We'd experience ipsilateral sensory deficits for discriminative touch, pressure and vibration, as well as proprioception. So we would see contralateral deficits in the spinothalamic pathway and ipsilateral deficits in the dorsal column medial lemniscal pathway. So the key takeaway from these sensory pathways is to understand the points of decussations for the different pathways. So for the spinothalamic pathway, it's going to be carrying contralateral information up the spinal cord the entire length. Therefore, if we have any sort of lesion above that level, it's going to cause contralateral deficits in that spinothalamic pathway. Similarly, if we have a lesion below the brainstem or the medulla for the dorsal column system, it's going to have ipsilateral effects, because remember, the dorsal column travels ipsilaterally up the entire length of the spinal cord before it reaches the brainstem, at which point it decussates. So it's important to understand the points of decussation and what that's going to mean if you have a lesion in the spinal cord at any particular area. So similar to how we saw in the dorsal column medial lemniscal pathway, we also have a similar somatotopic organization found in the lateral spinothalamic tract. However, it's going to be arranged slightly different. We're actually going to have information from our cervical dermatomes be more medially, and then information from our lumbar and sacral regions be more laterally. And this is because when information is coming in at a certain spinal level and synapsing on that second order neuron, this neuron sends its axon into that lateral cortical spinal tract. And let's say we're low, we're at the bottom of the spinal cord. It's going to add to that lateral column. So we're going to have information from our sacral dermatomes coming into this lateral column, and then we're going to build on it with our lumbar dermatomes, and then our thoracic dermatomes, and then finally our cervical dermatomes. So you can see how the organization, somatotopic organization for the spinothalamic pathway, differs from that of the dorsal column medial lemniscal pathway. So why is this important? Well, if we have some sort of intramedullary or extramedullary tumor or lesion that is slow growing and compressing on that lateral spinothalamic pathway, how might we begin to see sensory deficits manifest over time? Well, if we have a cervical intramedullary lesion slowly compressing laterally, we're going to first start off by loss of pain and temperature sensation in the cervical region, and then as it moves over, you're going to see those sensation deficits, or those sensory deficits, descend the body. So we're going to lose sensation in our thorax as well as our lumbar and cervical region as it grows laterally. Now, if we have a cervical extramedullary lesion, we're going to see the opposite. So if this is growing in and beginning to compress lateral to medial, then we're going to see loss of sensation in our sacral and coccyx region first, and then in our lumbar, and then in our thorax, and then finally in our cervical once it's grown large enough. So it's important to understand the somatotopic organization so you can understand the progression of a lesion and the sensory deficits that would follow. But anyways, that's it for the spinothalamic pathways and the anterior lateral system. I hope you guys found that useful, and if you have any questions, always feel free to reach out to us. I'll see you in the next one.